Lesson number 6, derivative of exponential function. So suppose I have the formulas for exponential function is very simple. The derivative of e to the u is equal to e to the u du. Alright, as simple as that. Let's try to have example number 1. Suppose my y is equal to e to the 4x. So again, our y prime, by just following this formula here, it says e to the u. Our u is 4x. So it says e to the 4x, e to the 4x times the derivative of your u. And your u is 4x. So therefore the derivative of your u is 4. Let me just use red pen. So therefore the final answer now is 4e to the 4x. Or what you can actually do is take first the derivative of your u, then copy the e to the u, the end, so you don't need to rearrange it. You're saving time. So for example, I have my second question, like 3e to the 3e to Alright, so let's say I have here question number 2, y is equal to 3e to the 1 minus 2x. So our y prime now, again, is e to the u du. Our u is 1 minus 2x. What we can do is take the derivative of our u first. So the 3, just copy it. The derivative of 1 minus 2x is 0 minus 2, or minus 2. So minus 2 there. Then copy your e raised to 1 minus 2x. So you have here now negative 6 e to 1 minus 2x. Let's try to have example number 3, but at this time we're going to combine it with with the other function. So let's say I have y is equal to x cubed e raised to 2x. So again, this one, there are two functions and the operations between them is product. So you're going to use the product rule, which is u prime v plus u v prime. So our y prime now is u prime, the derivative of x cubed is 3x squared times your v, just simply copy your v, plus your u, which is x cubed, times the v prime, the derivative of that, again, is times e to the 2x, and the derivative of 2x is 2. So let's write y prime now is equal to 3x squared e to the 2x plus 2x cubed e to the 2x. If you would like to rewrite it further, you can factor out the x squared and the e to the 2x. So 3x squared e to the 2x divided by this will have 3 there plus, 2x. So that is now your final answer. Let's try to have example number 4. Example number 4, let's say I have my y is equal to e to the x squared divided by 1 minus e to the x. Again, this one is a quotient problem. This is a quotient problem, so you need to use the quotient formula u prime v minus uv prime all over v squared, wherein your u is this, and that is your v at the bottom. So let's do the u prime. The u prime again is e x squared times the derivative of x squared, which is 2x, alright, times the v, which is 1 minus e to the x, minus your u, which is e raised to x squared, the derivative times the derivative of the v, which is negative e to the x, right? All over the v squared. V squared is 1 minus e to the x raised to 2. So this is now your y prime. Okay, that's equal to that. And we can simplify all of this stuff. Let's simplify it first. So y prime now is this you can multiply. Alright, so you have your 2x e raised to x squared plus e raised to x squared plus x. Because remember, you have the loss of exponent x to the m times x to the n is x raised to the m plus your n. So you can just simply add these two functions here all over 1 minus e to the x raised to 2. So that's our answer. Well, again, if you would like to factor this out, it doesn't matter if you would like to. So let's say, for example, let's factor this e to the x squared out. When you factor this one, so we can factor this. Okay, let's put it outside. So that's going to be e raised to x squared times this is 2x, all right, times 1 minus e to the x. Then this is plus e to the x. If you like to factor it that way, that's also all right. 1 minus e to the x raised to 2. All right. So thank you very much. So that's all for the derivative of exponential function.